to Module 16 of Modeling and Simulation, Part 1. In this module, we will address collectives. At the end of all three parts of this Module 16, you will be able to explain what collectives are and several ways of modeling them. This includes using NetLogo breeds to represent kinds of turtles and NetLogo links to represent relations among turtles of different breeds. You will also practice stochastic modeling by programming and analyzing a new example model of African wild dogs that live in packs, and we will explore logistic functions which are particularly useful for representing probabilities and functions that vary non-linearly between 0 and 1. So, on to collectives. Just like the Roman army you see in the top right of the slide, collectives are groups of cooperating individuals. In the picture here, you see the soldiers on the outside who have their shields in front of them, and the soldiers on the inside who hold their shields over there and their fellow soldiers' heads, effectively protecting the group. There are two types of collectives. The first one is those that emerge from agent behavior, like in the flocking model or in the Roman army, where the behavior protects the group and reduces individuals' vulnerability. The second one is those that are designed as agents. For example, the student body at a university or a pack of wolves. For those collectives, we have rules on how new individuals are added. In NetLogo, we typically want to consider collectives and their submodels as a simplified model of the individuals. This simplifies our coding considerably. So, how do we set collectives up in NetLogo? In NetLogo, we can represent collectives in two different ways, as patches or as links. If the individual agents in your model are turtles, it makes sense that collectives of turtles become patches, especially when individuals in a group occupy the same space, for example, animals or people that live in a family or social groups that each occupy a territory. The primitive turtles here is particularly useful because it provides an agent set of member turtles. On the other hand, links might seem natural for modeling collectives because a collective is a group of individuals that are linked in some way. However, NetLogo does not have a built-in way to give variables or rules to a network of linked turtles, only to the turtles or to the links. This makes it a bit harder to use links to represent collectives with their own behaviors. And that's where breeds come in. Breeds let you create several specialized kinds of turtles with different characteristics from each other, while still sharing some common variables and submodels. Here are a couple of caveats. Breeds need to be defined at the top of the program. Turtles have a built-in state variable called breed. If you create a turtle using createTurtles, its breed variable is set by NetLogo to turtles. You can change the breed variable by using setBreed, and each breed can have its own unique state variables defined with a breed's own statement. Lastly, each breed has any of the built-in variables that NetLogo also provides for all turtles. Note that you can still use turtle's own to define variables that all breeds use, and that you can use ask whatever breed you have defined to do something as a group. However, if you use ask turtles, all turtles of all groups will perform the action. Several of the agent set primitives have breed versions. For example, sheep here reports an agent set of the sheep on a patch, while turtles here reports all turtles on the patch. Lastly, all breeds are treated as if they were in turtle context, which is why you can't use variables that are specific to one breed in a different breed. If you do, you'll get a runtime error. Here is one example that we already know, the telemarketer model. Take a look at the code in the box. Here we see that agents that grew quickly did not survive very long. It would be interesting to create two breeds of telemarketers, the growers and the savers, that differ only in the parameter controlling how rapidly they expand and include both in the same simulation. Likewise, we could analyze the effects of mergers in the business investor model by letting a breed with a behavior of forming mergers compete against a breed that does not merge. So here's a summary about breeds. We can use breeds as one way to model collectives. We can represent individuals as one breed while representing collectives as a separate breed with different variables and submodels. And we need to keep good track of the connection between collective and individuals. Each time an individual leaves or joins a collective, we need to remove it from or add it to its collective's agent set of members. But we also need to update the individual's variable for which collective it belongs to. Forgetting to create or update these collective membership relations is a common mistake that can be hard to find. And here is what you have learned in this module. Pause the video for a moment to read through these items and ensure that you're comfortable with everything on this list.